In the early 20th century, Japan was racing to build a modern industrial nation. Factories were rising across the country. Science promised a better future, and chemistry was at the heart of it. In one of the coastal towns of Japan, one factory began producing acetaldehyde, a key ingredient for many industrial materials, and one might say vital for Japan's growth. The factory expanded rapidly, producing massive quantities of the chemical. It eventually became a market leader, bringing jobs, prosperity, and hope to the people of the town. But that progress came at a price. No one really noticed at first, but then the signs began to appear. This is the story of how one company's pursuit of progress poisoned an entire town, and how the principles of Adhishthana revealed that something was wrong all along. In 1932, a company called Nippon Chisso Hiryo, better known as Chisso Corporation, started producing acetaldehyde at its plant on the bayside of Minamata, a small coastal town in Japan's Kumamoto prefecture. At the time, Japan was rapidly industrializing, trying to rebuild and catch up with Western economies. To fuel that growth, the country leaned heavily on its chemical industry. Now, acetaldehyde became one of the key building blocks of that progress. It was an important chemical because it was used to make plastics, synthetic fibers, resins, and was used across the textile and consumer industries. The demand for the chemical was rising, and Chisso wanted a piece of that growth. Now, to make acetaldehyde, Chisso used mercury as a catalyst. Why? Because it was efficient, scalable, and one might say the only industrially viable method back then. But there was one big downside. It created a highly toxic byproduct called methylmercury. Now, methylmercury is essentially invisible. I mean, it has no color, no smell, yet it's considered to be one of the most dangerous forms of mercury known to science. For decades, Chisso Corporation dumped its wastewater contaminated with mercury compounds straight into Minamata Bay. In total, it's estimated that around 81 to 150 tons of mercury compounds were released into the sea over a span of 36 years. While the effects of this began to appear early on, no one really connected the dots. Fish started dying, seaweed stopped growing, and one of the strangest signs was seen in cats. The cats in the town twitched, convulsed in the streets, and leapt around wildly before collapsing. People in town even gave it a name, the dancing cat phenomenon. Symptoms in human followed soon after. While some early cases appeared around 1954, it wasn't until April 1956 that the first human case of mercury poisoning was officially reported. It was a young girl who was hospitalized after she suddenly lost control of her limbs and was unable to speak or eat. Just days later, 3 more patients were admitted with the same symptoms. The director of the Chisso factory hospital back then, Mr. Hosokawa, realized that there was something wrong. So he reported these strange cases to the Minamata Health Center on May 1st, 1956. That report became the first official recognition of mercury poisoning in Minamata. To understand exactly how the mercury reached the humans, we will have to understand the entire food chain, because when Chisso began releasing untreated mercury waste, it didn't just pollute the water, it destroyed the very ecosystem that had sustained Minamata for generations. Here is how it happened. After the compounds were dumped into the water, some of the mercury compounds were absorbed directly by pelagic fish through their gills and accumulated in their muscles. Those smaller fishes were then eaten by larger carnivorous species living in the same waters, passing the mercury up the food chain. Simultaneously, mercury also entered phytoplankton drifting near the surface. These then were eaten by small organisms which were eaten by larger ones, gradually increasing the concentration of methylmercury at each step. When these contaminated fish and phytoplanktons eventually died, their bodies sank to the seafloor, becoming food for benthic animals, which were again contaminated. And when those were caught by local fishermen and brought to the market, the poison came full circle. The same toxic compound that had started at the factory now entered the bloodstream of the people of Minamata. Over time, this invisible cycle became a slow-moving poison, contaminating species one by one. And it didn't even stop there. It even moved into the next generation. When pregnant women ate the contaminated seafood, the poison passed through their bodies and into their unborn children. Babies were born with severe disabilities, what doctors later identified as congenital Minamata disease, a condition in which mercury crosses the placenta and damages the developing brain. Later, researchers Nishigaki and Harada confirmed this through their studies on umbilical cords, showing exactly how methylmercury had made its way into the next generation. I would recommend reading their research papers for a deeper understanding of the subject. Soon after the outbreak of these strange cases in 1956, Japan's Ministry of Healthcare and Welfare launched an investigation. By early 1957, their researchers already suspected that fish from Minamata Bay might be carrying the poison, and even recommended examining the link between the factory's wastewater and the local seafood. Around the same time, Kumamoto University went a step further. They urged the prefectural government to ban fishing altogether, warning that the bay was contaminated and the Food Sanitation Act should be enforced. But that ban never came. The Ministry of Health and Welfare dismissed the proposal, saying that there wasn't enough evidence to justify such action. What's even more concerning is that the mayor of Minamata at the time, Mr. Hashimoto, the same person who had designed Chisso's acetaldehyde plant and served as a director over there, was among those who opposed applying the Sanitation Act. With all this happening, it's natural to ask, what was Chisso doing while people were getting sick and dying? Rather than investigating the cause, Chisso spent its energy denying responsibility, and they did it on three main grounds. Chisso argued that if they had been producing acetaldehyde since 1932, then why did symptoms only appear after 1954? Secondly, they said that other factories used mercury as a catalyst too, then why were only they being blamed? Lastly, they insisted that inorganic mercury couldn't turn into organic mercury naturally, so their process couldn't be the cause. For this video, we'll focus on the first point, but if you want to explore the others in detail, I highly recommend the book Mercury Pollution in Minamata by Professor Hisashi Yokoyama. He lays out step by step why each of Chisso's arguments were baseless. But why did the symptoms show up only later? The answer comes down to a small change in the factory's chemistry. Around 1951, Chisso switched the promoter used in their acetaldehyde process. A promoter is a secondary chemical added to boost the speed and yield of a reaction. Before 1951, Chisso used magnesium dioxide as the promoter. That setup kept mercury relatively stable. It stayed in its inorganic form for a long time. It was less reactive and less likely to turn into methyl mercury easily. But in 1951, Chisso changed the promoter to a new combination: iron sulfate and nitric acid. This change was made to improve efficiency. The new promoter sped up the reaction, increased yield, and reduced downtime in the plant. In short, it made production faster, smoother, and far more profitable. The problem was that this combination also made the mercury far more reactive. The new conditions helped convert mercury into such a state which could be easily transformed into methyl mercury by bacteria in the water. The result was devastating. This small change likely increased the amount of methyl mercury released into the Minamata Bay by 10 to 20 times. Also, if you look at Chisso's production records, it's clear that it's only after 1950 that the company's acetaldehyde output skyrocketed, and so did the mercury emissions. And it is because of these reasons that the symptoms appeared in 1954 and not early on. Chisso was well aware that inorganic mercury could be converted into organic forms under natural conditions. They knew the risks, but they made the changes anyway, choosing profit over precaution. The time the company finally stopped producing acetaldehyde in May 1968, the damage was already done. There is no single definitive count of how many people lost their lives, but reports suggest that more than 2,000 lives were lost and over 100,000 suffered serious health effects from the contamination. In 1973, the Minamata District Court found Chisso responsible and condemned their action. Since then, the company has paid billions of yen in compensation. But even today, more than 1,400 people are still waiting just to be officially recognized as victims. This wasn't just a chemical accident. Chisso was aware of their wrongdoing and they still continued. It was a failure of awareness, a failure of responsibility, and a failure at the very foundation on which progress was being built. What happened in Minamata wasn't random. It followed a pattern that in hindsight showed clear signs of imbalance long before the disaster. The principles of Adhishthana have revealed such patterns across history, in markets, in disasters, and in moments of collapse. So the question is, did those same warnings appear here too? For those who have read my book or have been following our market commentaries, this part will feel familiar. But for the first time viewers, let me give you a quick introduction. The principles of Adhishthana form a framework, a set of ideas that explain how the universe organizes itself. They are universal and can be applied to almost anything: financial markets, natural disasters, nuclear events, or even historical tragedies like what happened in Minamata. The framework divides everything into 18 distinct phases, each with its own characteristics and interpretations. So to study this event through the lens of Adhishthana Principles, we looked at Chisso's acetaldehyde production data from 1932 to 1968, the same period during which mercury was being released into Minamata Bay. Now, under the Adhishthana framework, the stretch between phase 4 and phase 8 forms a very distinct pattern known as the chakra, a kind of an arc formation that represents conservation consolidation within the underlying system. You'll often see the same pattern in financial charts too. Here are a few examples of how a chakra typically appears. You can see how it stretches out and tilts towards the upside. So normally in phase 9, the underlying breaks out of this chakra formation on the upside. This marks the beginning of what we call the Adhishthana Himalayan formation, a three-legged move representing ascent, peak and descent. But sometimes the chakra doesn't break on the upside. Instead, it breaks on the downside. And when that happens, it triggers something known as the move of pralaya. A breakdown from the chakra signals that something is fundamentally wrong within the underlying. It shows that the system's foundation has become unstable, and as a result, the structure is expected to collapse completely and sharply. And that's exactly what we saw when we plotted Chisso's acetaldehyde production data. The curve had been forming a clear chakra pattern since phase 4, and in phase 8, which corresponds to the year 1965, it broke below its lower chakra limit, the very point where, according to the framework, a system reveals its inherent flaw. The breakdown suggested that something was deeply wrong, not just with the plant's production process, but with the foundation of its decision making, its ethics, and its purpose. And what's even more interesting is that this breakdown wasn't random. The data had been warning us decades earlier. The first warning sign was seen back in phase 2, which was between the period 1937 and 1944. Now, under the Adhishthana Principles, phase 2 is a dual move phase. It is divided into two parts, the move of Sankhya and the move of Buddhi. Typical pattern, the Sankhya phase represents consolidation. The underlying either stays within a range or declines slightly. Then during the Buddhi period, it transitions into a very strong upward move, a very exponential rise. But in the case of Minamata's acetaldehyde production data, the opposite happened. During Sankhya, instead of staying flat or falling, production began to rise sharply, largely due to post-war industrial recovery and Chisso's decision to expand output. Whenever an underlying rises prematurely during Sankhya, it tends to collapse during Buddhi. And that's exactly what the data revealed. As the production curve transitioned into the move of Buddhi, the trend reversed and production dropped. This early deviation showed that the production system was not moving in line with the natural rhythm of the Adhishthana Principles. This phase 2 mismatch, visible as early as 1937 to 1944, was the first warning, a quiet signal that something was inherently wrong with Chisso's acetaldehyde production. And when we examined the subsequent phases, we found similar deviations there as well, reinforcing the conclusion that the entire production process was unfolding in a fundamentally flawed way. And this is precisely why tracking and applying the Adhishthana Principles becomes so important across industries and events, because under the model, the first signs of collapse often appear long before the actual disaster itself. After such a dreadful event, one might think that the world would learn, that industries everywhere would realize the consequences of dumping toxic waste into the water, that they would understand how deeply it can scar both nature and people, and never repeat the same mistake again, right?